Okay, so I hope that you've noticed on all of these problems that we've done that the key to just about every single one of them is either a formula or a picture or both. A formula is obviously uh, the beginning. If you don't know the formula, you're not going to be able to answer the question. But the drawing the picture is where you're going to get the information that goes in the formula. So I know that I'm dealing with a regular pyramid. They were nice and gave me a kind of a picture, but they didn't have, the 3D image so that I could see inside it. So I added those little dotted lines so that we could see inside. And then I drew the apothem. Remember this base right here is a square. Does it look square? No, but they tell me that it's square. So I'm gonna have to know that that this leg. Why am I not drawing? That this leg and this leg and this leg and this leg are all the same length. The apothem goes from the center to the midpoint of any side. So I drew it right there because I thought that would be the most visible. But I could have drawn it here, could have drawn it there, could have drawn it there. So there's the apothem could have gone, in 3 other places other than the one that I drew it. They gave me the height. They tell me that the altitude. Now, if the altitude is the same thing as the height of the pyramid. They gave me that was 12, and they gave me the slant height. So I'm going to use this right triangle right here that's formed by these 3 pieces of information to calculate the length of the apothem. And the reason that I want the apothem is if I get the apothem, then I'm going to be able to know how far it is. I'm going to be able to know what the side length is, because the apothem goes to it's halfway. It goes from the center to here. And for a square, that's half the square. I noticed that the 2 measurements that are 12 and 13 ring of a 5, 12, 13 Pythagorean triple. If you're not sure about that, so my knowledge of my Pythagorean triples lets me know that that's 5. Of course, you could say that a squared plus b squared equals c squared, and that would be 144 equals 169. You subtract that, you get 25, and then your apothem ends up being 5. But see how much time I saved just by recognizing that it's a 5, 12, 13. So this is 5, so that means all of these sides around this thing right here are 10. I need the surface area, the lateral surface area. That's what they're asking for right here. And then the total surface area. The lateral surface area for a pyramid, I'm going to go look at my formula sheet. The surface area for a pyramid is 1/2 PL. So this is 1/2 PL. The 1/2 times the perimeter of the base. So that's 10, 20, 30, 40 times the slant height. And the slant height was 13. So 1/2 times 40 times 13 is 260. They give me units? No, they don't. 260, but it's units squared because it's a surface area though, a lateral surface area. So I may not have units, but it's units squared. And then the total surface area, let's go back and see what the formula sheet says about that. The total surface area for a pyramid is that number that we just found plus the area of the base. So we've got the number that we just found which is 260 plus the area of the base. And this base is a square, and the way you find the area of a square is length times width. So 10 times 10 is 100, so this is 360 units squared. Total surface area. All right, I think did they tell me to find the volume? I don't remember that, but I can certainly go back and find the volume. But we got the lateral surface area 260 and the total surface area is 360. So let's go back and see. Yeah, find the volume. There it is right there. I did not find the volume. So the volume is, the formula for the volume is, I believe 1/3. Here's the volume of a pyramid, 1/3 the area of the base times the height. Okay, so the volume is 1/3 the area of the base times the height. 1/3 the area of the base is 10 times 10, and the height is 12, the height of the pyramid. So we've got 1/3 of 12, I think, is 4, so that would be 400, and that's units cubed, okay? And I believe that's what we just saw on the answer sheet. Okay, so I'm going to move on to number 6. Number 6, I want you to notice anytime I get a picture this busy, I'm dividing it up into individual pictures. Every single one of these pictures that I have right here came from this big picture. And I'm simply taking them apart and only using the information that I need to help me find what I'm looking for. So BG right here, I could have drawn angle 1 with BG and 80, but that gave me 2 unknowns, and that wasn't enough information. So having 2 unknowns, I couldn't find anything. But then I noticed that FD right here, and it tells me, is a diameter. So if it's a diameter, then I'm working with, I know, 180 degrees. So all of these measurements right here, all of these together have to equal 180 degrees. So I've got every piece except for the measurement of this one right here that's highlighted. So over here I have 20 right here, plus 80 right there, that's 100, plus 40 right there. So I've got 140 degrees accounted for, but I know that I need 180 because this is a diameter. And so a diameter will cut the circle into 2 180 degree pieces. So that means that this one right here has to be 40. Okay, I just found out that BG is 40. So everywhere in this picture that I need, that I use BG right here, I'm going to be able to use 40. Because 20 plus 40 is 60, 60 plus 80 is 140, 140 plus 40, that gives me 180. Now, to find EF, I'm going to be using this interior angle. The angle was formed on the interior of the circle. It has 2 arcs, and since it has 2 arcs, I'm going to add those 2 arc measures together, take half of it, and that's going to be the measure of my angle. So my angle right here, which is 65, that's equal to half the sum of the 2 arcs. Now this arc, which is FE, I don't know. I'm going to call that X. And then the other arc is 40. Okay, so I know that if I have this angle plus 40 and I take half of it, I get 65. This is just an algebra problem. I'm going to start by getting rid of that 1/2. So I'll multiply both sides by 2, and 65 times 2, I believe, is 130. So 130 should be what I get when I add 40 and arc FE together. So subtract 40 from both sides, and that looks like FE right there is 90 degrees. Okay, well, if FE is 90 degrees, then DE is also going to be 90 degrees because, again, it's the other half of that semicircle. So together, those two arcs have to equal 180. So they're each 90 degrees, okay? Now, remember up here, I've already found BG. BG was 40. So I'm going to be able to find the measure of angle 1 because it's found on the exterior. It's an angle formed on the exterior. So I'm going to take the two arcs and subtract them and then take half of it. So the measure of angle 1 is equal to half the big arc minus the little arc. The big arc, which is 80, minus the little arc, which is 40. 80 minus 40 is 40. Half of 40 gives me 20. So the measure of angle 1 right here is 20 degrees. Okay, the measure of angle 2, same formula. Both of the angles both of the arcs, that belonged with angle 2, both the intercepted arcs, those were given information. So 40 and 20 were both given. It's an angle formed on the outside. So the measure of angle 2 is equal to 1/2 the big arc minus the little arc. The difference of the arcs. 40 minus 20 is 20. Half of 20 is 10. So the measure of angle 2 right here is 10 degrees. All right, measure of angle 3. This is an inscribed angle right here, so it's half the arc. We found the arc was 90, so it looks like the measure of angle 3 is 45. The measure of angle 4 right here, we found BG up there on the first part to be 40. So the angle 4, which is this angle right here, FEC, so F to C is the intercepted arc. So it's 20 plus 40 plus 80 is the arc that belongs to that angle. So that arc right there is 140 degrees. So if that's 140 degrees and the measure of angle 4 is half of 140 degrees, so it looks like it's 70. Remember a while ago we found FE to be 90 degrees, so angle 5 is 45. It's an inscribed angle, so it's half the arc. And then angle 6 is also an inscribed angle, so it's going to be half of its arc. FE was 90. We calculated that. GF is 20. That was given. So we need half of 110. And half of 110, I believe, is 55. So the measure of angle 6 is 55. I'm going to let you go check the answers because that's a lot of them. But 40, 90, 90, 20, 10, 45, 70, 45, 55. So it looks like I got them all right. And then number 7 will be the last one on this video. The areas of two similar triangles are 144 and 256. Now you got to remember that we can take those and write a ratio out of them, 144 and 256, okay? But remember, this right here is the ratio of the areas. So that means that the ratio of the areas, that's equal to your scale factor squared. So what we want to do to find out what the scale factor is take the square root of that, because we want to find the scale factor, so we want to take the square root of that in order to find what the scale factor is. So you take the square root of that and you get 12 over, what is the square root of 256? Is that 16? Yes. So that's 12 over 16. Now 12 over 16 reduces, so I'm going to reduce it so that I can use smaller numbers. And 12 over 16 will both reduce by, let's see, 4. That's 4 times 3, and that's 4 times 4. So those 4 cancel out. So my scale factor is 3 to 4. So I'm going to use that scale factor now. If 3 to 4 is my scale factor, then I'm going to put 9, because it's from the smaller figure, and its corresponding part, which is from the bigger figure, it's going to go on bottom. And now I'm going to cross multiply and divide. So 3x is equal to, I think 4 times 9 is 36. So that means x is equal to 12. So this side length right here should be 12. And I believe that's what we just saw a peek of that. Yeah, number 7 right there is 12. Okay, so that's the end of the first 7 questions. My next video will pick up with question number 8.